So for question number 11, we know that we are still using the point 2, negative 15. And this time we're going to write an equation that goes through that point, but is perpendicular to that line, 9x minus 3y equals 63. Well, this doesn't really give me my slope to borrow. So let me get that 9x minus 3y equals 63. Let me get that into slope-intercept form so I can see what my slope is going to be. So I do that real quick by subtracting 9x from each side. And I get negative 3y equals 63 minus 9x. So I need to get y by itself, so I divide both sides by negative 3. So negative 3 is going to cancel out negative 3, giving me y by itself. And then I'm going to put my x term first. So negative 9 divided by negative 3 gives me positive 3x. And then 63 divided by negative 3 is going to give me negative 21. So I know that that equation right here equals y equals 3x minus 21. They're the same. I just put it into slope-intercept form. So now that I've done that work, I need to figure out what is my slope perpendicular to that equation that we just figured out. So perpendicular means the slopes are opposite reciprocals. So if my slope here is positive, I know that my new slope going through this coordinate 2, negative 15 is going to be the opposite. So if it's positive for the 3, it's going to be negative for the line going through 2, negative 15. Perpendicular lines are opposite reciprocals. Now that we've made it an opposite, I've got to make the 3 over 1 a reciprocal. So 3 over 1 flipped is negative 1 over 3. So my slope in this case is going to be m equals negative 1/3. So all I have to do is write my equation in point slope form for the first one. So I've got y equals, I'm so used to slope intercept form. I have point slope form, which is y minus y1. So y minus a negative 15. I know that two minuses make a plus, so y plus 15 equals m, negative 1/3, times x minus x1. So that's my equation in point slope form that is perpendicular to the 9x minus 3y equals 63. Now to get it into slope-intercept form, I'm going to get the y all by itself. But before I do that, let's clean up the distributive property. We know negative 1/3 x is just negative 1/3 x. And negative 1/3 times negative 2 is going to give me positive 2 over 3. Remember, 1/3 times 2. A negative times a negative gives me a positive, and 1/3 times 2 is like taking 2 over 1. I can't cancel before I multiply, so I have to do top times top, bottom times bottom. So negative 1 times negative 2, again, is a positive 2, and then 3 times 1 is 3. That's where the 2/3 came from. If you're having a hard time with the fractions, make sure you review before the test tomorrow. There's going to be fractions on the test. So now that I have that, I need to get y all by itself. So I can subtract 15 on each side, but I know automatically that when I have a fraction and I have a number that doesn't have the same denominator, I'm going to have to either find like denominators or I can get rid of my fractions altogether. I prefer to just get rid of the fractions. And again, just like in question number 10, the only denominator is 3. So my LCD that I'm going to get rid of my fractions with is 3. I'm multiplying both sides of my equation by that 3. So I've got 3 times y, 3 times 15. And then on the left-hand side, I'm going to get negative x plus 2. 3 will cross cancel into 3 one time. 1 times 1 is going to give me a 1 in front of the x. 3 into 3 cross cancels into 1. 1 times 2 is 2. Alright, just don't ignore the signs. A positive times a negative still gives me a negative. A positive times a positive still gives me a positive. So now that I have that, let me just get y by itself, subtract 45 on each side, and I'm going to get 3y equals negative x minus 43. Divide both sides by 3 to get y by itself, and I'm going to get negative 1/3 x minus 43 over 3. That is my equation in slope-intercept form. Now to get it in the standard form, I want to get it in the ax plus by. So let me go back to where my equation didn't have any fractions, because I know the standard form, there are no fractions. And I'm going to borrow that from before I divided by the 3 to put it in slope-intercept form. So to get it in the standard form, I'm going to add 43, I'm not going to add 43. I want to get x to the same side as y, not the 43. So I'm going to add x to each side. So x plus 3y equals negative 43. And that is my equation in standard form that is perpendicular to the line at the top that they gave us. So that's all three forms that are perpendicular. So I hope that helps clarify some things.